Okay, it looks like... Hey, you guys, it looks like you got it. Remember, this is a review for the test, Chapter 9 test on logarithms. Okay, you guys got this, and let me show you 2 ways to get this. I think a lot of you forgot the first way I taught you to do this. 64 can be written as 2 to the 6th power. Can anybody do it this way?
Yeah, I just figured out what 3x plus 1 equals 6.
Yeah. And then since they're both the bases are 2, that means the exponents would have to be equal if this is equal. And then I can just solve that equation, right? Okay, that's a fast way to do that one. Not all equations can do that. It just happened to be that 64 can be rewritten as 2 to the 6th power. Most of you probably took the log base 10 of both sides. Is that right? And then you use the power property to bring the 3n plus 1 down in front. And then you divided both sides by log of 2. They canceled out over here, and you did log of 64 over log 2, and you should have gotten 3. Is that what you got? And then you solved that equation, and your answer was, no, you should have gotten what? 6. Yeah, you should have got 6. And then you solved that, and you should have gotten n equals 5/3. Is that what you had? Okay, good job on that one. Second problem. There you go. Okay, it looks like all the tables had it. You just had to use, you guys had to use the change of base formula. We used base 10, the common logarithm. Remember? And you should have gotten about 1.5. Is that what you got? Exactly. It's actually exactly that. How did you get 4 point? Oh, is that why you had it off a little bit? I thought it was there. Okay, change of base formula. Don't forget the change of base formula. Remember, you can use any base that you want. In fact, I want you guys to do this. Everybody just do ln of 729 over ln 81. So you can do base e. That's what the natural logarithm is, base e. You should get exactly the same answer. Okay? All right, next question. Solve that equation. Hey, you guys look, since both sides are log base 8, we know since they're log base 8, the only way this can be equal is if the x squared plus x equals 12, right? So anytime those are the same, we can just drop that. Now that's a quadratic equation. So we set it equal to 0. We factor it. Factors to be x plus 4 and x minus 3. And then, so we get the answers as -4 and 3. Now, a lot of you guys, I was glad to see this, because the other class I must not have emphasized it in there. But you have to check for extraneous solutions. Well, the thing about this one right here, you guys, if you put this negative number in here, -4 squared is a positive 16. -4 would be a positive 12. So that number right there would be a positive 12. So it actually is not an extraneous solution. Okay, so both solutions work in this case. Okay, now it does not, when you should always check your numbers to make sure it does work. Even a positive number sometimes won't work if your expression up here gives you a negative number once you put it in. So you got to check them. Okay, did you still have that question, Colby? You got it. Okay, here we go. Next one. Right here. Keep in mind, you're going to have to write it the left side as a single logarithm. Keep in mind the power property, the product property, and the quotient property when you do this one. Okay, excellent job. Hey, by the way, so just to make sure you guys understand, we had to use the power property to bring that up. So we had log base 5 of 4 to the 1/2 power. Now, we just discussed when we were doing that quiz trade activity, 4 to the 1/2 power is what? 2, because it's really asking for the square root of 4, right? So I have log base 5 of 7 plus log base 5 of 2. I'll just write that down over here because some people at home might not remember that. 4 to the 1/2 power is the same thing as square root of 4, which is 2. That's where we got this 2 from.
7 times 1/2 log 5 28.
No, the order of operation would have to be done this way. No, the square root of 28 is not,
Not square root.
I mean, not, well, you would have, no, yeah, but that's not the same thing. That 1/2 is a power. Yeah, but the 1/2 is a power. Don't forget.
Well, yeah, but when you're moving, you have to move the front end. You have to move the front times 5 1/2.
Oh, okay, I see what you're saying, yeah. Yeah, you could do it that way. Yeah. Actually, you could. Good job. Good thinking, Colby. Zach. Well, let me finish this one really quickly. Using the product property, we have log base 5 of 7 times 2. We get to times these two numbers together using that product property. 14 equals log base 5 of x. Since they're both log base 5, the only way they can be equal is if those two things are equal, and so we get x equals 14. You guys did a good job on that one. Zach, are you asking about the previous one? Because negative 4 squared is 16. And then that would be negative 4. 16 minus 4 is a positive 12. It's just that the number, whatever base you have, the number right here that goes in for x, I mean, that final product has to be a positive number. Now, there is an exception to that. If I have something like 2 log base 5 of x, and let's say I get a solution that's negative, and you know this using the product property or the power property, you can put it up there and go x squared, but it's still a extraneous solution because I had to move it up there to do that, and so the original problem was not there. Whereas this one, you can't use the power property with that one. Okay, so just keep that in mind. Okay, we did this one. Okay, next one right here. You guys are doing really well with these, actually. I've been impressed. Okay. Hey, nice job. You guys, this one was a little bit tougher, and you just got to remember to change it to exponential form. So, first of all, I'm going to move the 2 up using the power property. Okay, then I'm going to combine this into a single logarithm using the quotient property. So I take x squared, which is the first one, divided by x3 equals 2. Now, when we got here, there was at least 2 tables that I saw. Well, listen, because this is a common error. At least 2 of you guys wanted to cross this with one of the x's on the top. You remember, you can't do that when you're adding or subtracting. You can only do it when everything's being times on the bottom and times on the top, okay? You can only cancel factors. Factors are numbers being multiplied. So you can't do that. What you can do at this point is change it to exponential form. This number right here is the base of the exponent because it's the base of the logarithm. This number here is the exponent, right? Logarithm is an exponent. And what's left is the x squared over x plus 3. So now you have this equation that you have to solve. That equation, as it's written, is a rational equation, right? So I have an x in the denominator. How do I get rid of an x in the denominator? Okay, I'm going to multiply both sides by the denominator, x plus 3. Do you guys see that? And 2 squared is 4, and I distribute the 4, and I get 4x plus 12 equals x squared. Now I've turned that rational equation into a what kind of equation? A quadratic equation, because it's x squared. So I don't want my x to be negative, so I'm not going to minus a negative x squared to both sides. What I'm going to do is minus 4x and minus 12. So I get 0 equals x squared minus 4x minus 12 equals 0. And then I'm going to factor that. Whoops, I already put an equal 0 on the front of it, didn't I? So then I'm going to factor it. It factors to be x minus 6 times x plus 2, because 2 times negative 6 is negative 12, 2 plus negative 6 is negative 4, which leaves me as the solutions as x equals 6 and x equals negative 2. And if you check 6 and negative 2, you'll notice that negative 2 if I plug it in right here, I'm going to have a negative number right there. I know I can bring that 2 up and square it, and it would be positive, but the original problem showed that this x right here, and if I put that negative 2 in there, I'm taking the logarithm of that, and that's, you can't do that, okay? It's not in the definition of logarithms. So the answer is just 6. Negative 2 would be an extraneous solution. Well, technically, if it can be written, if you can rewrite it with a power property, then no, you can't. Then that would be an extraneous solution right there, okay? Like on the previous problem that where it had x squared plus x, we couldn't write it as a power property. Couldn't use the power property in that one because there was 2 terms being added. All right? Okay, yeah. 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 So when you're using the quotient property, that's a good question. When you're using the quotient property, you guys, it's always the first number divided by the second number when you're using that quotient property. Okay? Left to right. Did you guys hear that? Okay. Now, this one's actually easier than the other one. You just got to do some simplifying of numbers. It looks longer, but it's not. Okay, looks like most of you had it. Okay, if we use the quotient property, you guys, we're going to get 48 divided by 16/5. Right? Whoops. Okay, so now, you guys, if I take 48 and I divide it by 16/5, that's the same thing as timesing it by 5/16, right? 16 will go into 48 3 times 5 is 15. So this is really log base 6 of 15 when you simplify it. Log base 6 of 5 equals log base 6 of 5x. Then we use the product property to combine these two. So you multiply 15 times 5 and you get 75. And then since they're both log base 6, that means 75 has to be equal to 5x to make that true. Divide by 5, and you get x equals 15. Good job on that one. Okay? Got it?
Yeah.
What questions do you have on it? Do you understand that we combined the first two using the quotient property? So I divided 48 divided by 16/5. Now I showed you over here, to simplify that, you go 48 divided by the reciprocal of 16/5, which is 5/16, right? 16 will go in 48 3 times 15. That's how we got the 15 here. And then we combine these two, Colby, using the product property. 15 times 5 is 75, right? So that's log base 6 is 75. And since these are both log base 6, you can just set 75 equal to 5x and solve that to get your answer. Jessica. That's a good question. I probably would work, I'm guessing. Let's try that. Did you guys hear what Jessica said? She's saying, what if we did this to both sides? Okay, so if we added log base 6 of 16/5 to both sides, use the product property, then we'd have log base 6 of 48 times 5. Add 48 times 5 for me.
48 times 5, that's
240. I knew that. Did you do that in your head, Logan? Did you do that in your head? Nice job. Okay. Log base 6 of, and then we have log base 6 of 16/5 times 5x. The 5's will cancel out, and you'll get 16x, right? So log base 6 of 16x, is that what I said? And so 240 equals 16x. Divide by 16, and x is equal to what? 15? Same answer, yeah. It works. Good job. Okay. Here we go, next one. Oh, we're getting easier. Looks like every group had it. But, you guys, I would take the common log, which is log base 10 of both sides. Keep in mind, you could do the natural log of both sides. Then I use the power property to bring x squared down. Then I would divide both sides by log 2.3. So I'd get x squared equals log of 66.6 over log of 2.3. And then I would take the square root of both sides. Okay? Any questions there? And you should have gotten, what'd you guys get? 2.2245? Is that what you said? Okay, good job. All right, next one. Two to the x equals 53. Now we're even getting easier. Looks like every table had it. So we go log 2 to the x equals log of 53. So that's using the power property. We bring the x down in front. Divide by log of 2. Put that in your calculator. And you guys got 5.7279. 5.7279. Any questions on that one? So you just got to remember, take the common logarithm of both sides, use the power property, divide. Okay? Next one. Okay, now this one's done the same way, except for you've got variables on both sides. So you're going to have to do a little distributing and then solving at the end. Okay, so looks like some of you got it. So I'm going to skip a step. We know that we can bring 3y down if we do log of base 10 of 6. Log, and then we can bring the y minus 1 down. Remember, I need to put parentheses around that. Did you guys put parentheses around it? Because you got to distribute that. I'm going to divide both sides by log of 8. You can divide both sides by log of 8 of 6 instead if you want. It doesn't matter which way you do it. So I know that the logs of 8s cancel out over here, and so I have y minus 1 on that side. On this side, log of 6 divided by log of 8 is what? Someone give me a decimal to like 4 decimal places. 0.8616. Okay. Now I times that 0.8616 times 3. What does that give me? 2 point something. 2.5848. Is that what you said? 49? 48? 49? 49? Okay. Doesn't matter probably. So, y. That's a y right there, right? And then I have to minus a y, 1y from both sides, you guys. Minus 1y, right? So I'm going to minus y from that, and that's going to give me 1.5849, because that's supposed to be a 9, right? Y equals negative 1. Divide both sides by 1.5849. Negative 0.63, what? 0.9. And there's your answer. Is that what you guys said? Okay. Good job. What? Yeah. Okay, next one. Okay, we get back to a little bit easier right here. Don't know why I did that, but I did. Okay, go. Do I even need to do this one? You guys all got it right. 8.009? Is that what you had? Okay, good. All right, next one. All right, hey, now we're getting to base E, which means you can use what? ln, right? ln. Okay, good job. looks like you guys got it. We add 4. Whoops. Add 4. 2ex equals 5. Divide by 2. We get 5/2, right? Now, let me remind you of something, because I saw some of you guys just changed it to exponential form, but let me just show you a quick trick. If we take ln of both sides, so remember, if I take ln of both sides, ln e to the x is just x. Remember, if you take ln e to some power, it's just the power. So you have to take ln of 5/2, and what did you guys get for the answer again? 0.9163. Was it negative or not? Okay. Good job. Hey, you guys remember, ln e to the 5x, what does that equal to? 5x, right? ln e to the 7 is equal to what? 7. The reason that is because log base e of e to the 7, if you're going to change that to exponential form, you'd go e, the base e to the power x equals e to the 7th. That means x equals 7. So anytime you have ln e to some power, it's just the power. Okay, next. You know what? Stop. Okay. Next time we come to class, remind me, you guys, we have 4 more left. 12, 13, 14, and 15. Okay, so here's the deal. For the test, it will be Wednesday next week, next time we meet. I would suggest you do that review in your book. The end of chapter 9, there's a review. I would go through 9-2 through 9-5. You don't have to do it if you don't want to. If you want to know what's going on, you can do it. Next, hold on, don't move yet, you guys. Listen. Next time you come to class, I'm going to finish these 4 problems as a review. Plus, we're going to do a quiz trade that will review all the properties and also changing from exponential form to logarithmic and logarithmic to exponential. Then we will take the test. That's all the review I'm going to do. And 9-5 will be due next time. So 9-5 will be due next time. Yeah, you got a whole nother week to do it. Okay? So have a great Easter break. Put everything away. We'll see you. Hey, and you can watch this video again if you want to. It's only 22 minutes long.